Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Kinematics, mechanics, kinematics playlist. And today problem still about one-dimensional movement, although we have the plane that should go here and the wind that blows from here. So it's not really one-dimensional, but if we look closely, we know that it's one-dimensional movement. Because in order to go straight from north towards south, when the wind has this component that not only slows us down, but moves us to the side, because the wind is blowing this way. But we can say that it's exactly like one component slowing us down when we're moving this direction, and another component is drift us to the side. So we have two components of the wind, and that's how we will approach it. So in order to not be moved to the side, we can direct our speed of our aircraft, and let's lose the W. W for the aircraft, and let's use W. Let's use W for the wind, of course, because wind is W and aircraft is V. So we have those two vectors, and this should be beta, and this is alpha, and it's known. And so we have two components of the wind. So instead of talking about the true vector, we split it in two vectors. And we can say that the sum of this vector and this vector is this vector, and this is absolutely true. And this vector is going against from south to north, and this vector is going from east to west, right? And so in order for us that this vector should be compensated by this component, and then this component would be directed here, and so in this way the aircraft will go straight by this line, and only if this component is equal to this component. But if this angle is beta and this is V, this component, that is this, directed in this way, it's V sinus beta. And if we look on this wind, on this vector, this is this vector, it should be W sinus alpha. And those two components should be equal to each other. So we have first equation, and I can write it here. V sinus beta equals W sinus alpha. Okay, now let's check what's going from here to here. From here to here, the speed of the aircraft is V cosine alpha, because this is this component. This component is exactly V cosine alpha. Cosine beta, because this angle is beta. And this component is W cosine alpha. And so when aircraft is moving from here, this of course has to be bigger than the wind component. So the total speed would be V cosine beta minus W cosine alpha. And this is the speed with which we are moving, and in this problem we know d and we know time. D and t is given to us, and also we know that aircraft is moving straight from north towards south. So in the end we just know that d and t are given to us, so we know that with all those components, this way, that way, this way, that way, looks like it's two-dimensional, but it's not two-dimensional movement. The two-dimensional components, but the movement is still one-dimensional along the straight line. Distance d is covered during the time t, and this is the speed. D over t is equal this. So this is our second equation that I'm going to write here, but we will have two equations now. dt is known, alpha is known, wind is known, so what is not known is v and beta. V and beta are not known, so let's write those two unknown things. I will move them so they all will be on one side, and on this side we will have d over t plus w cosine alpha. So once again, v is the speed of the aircraft and it is unknown. Beta is the direction where aircraft should go, and it is also unknown. But what is known is speed of wind, the angle, and also d and t, the time that has to be covered at certain time, certain distance. So all of these are known things, those things are not known. So how to find this? V and beta, and thankfully they are on one side. So there are many ways to do it, but it's basic trigonometry. So we can divide one over another. For example, v would be gone, and we will have only beta, sinus, sine divided over cosine, and it will be tangent. So this is one thing, and we immediately will know beta. We know tangent of beta, and then we will know beta. And then another thing that we can do is we can get rid of beta. How will we get rid of beta? We take square, so it would be sine squared and cosine squared, and this would be v squared, and then we add those together, and when we add those together with the sine of the angle, sine squared plus cosine squared, and it will be 1. So let's do the first thing. Let's divide. V would be gone, so v sine beta divided over v cosine beta, and we will have w sine alpha divided over d over t plus w cosine alpha. And I don't want to rewrite it. I simply say v is gone, and sine over cosine is a definition of tangent. So it would be tangent beta equal. So plug the numbers and got the tangent, take our tangent, and this you can do of course with a calculator, and I'm not going to repeat it here. Now let's do this transformation with this. As I said, square, 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 square. Same here, square, square, and this is the number squared. And then take a sum, plus, and we will have v squared sine squared beta plus v squared cosine beta plus equals this w squared sine squared alpha plus, I don't want to rewrite it, plus this bracket squared. V squared can be factored out, and there would be sine squared. When I factor it out, there would be sine squared. Although I know better, I can plug it here in any equation, but why bother? Because instead of plugging at it, and I don't want to repeat this right section, instead of plugging it, I immediately receive this sine squared plus cosine, which is 1. And I have v squared equal. And I repeat this, w squared sine squared alpha plus this bracket squared. And the last thing, I have to take a square root. You can do it yourself. It's very simple. But basically, to emphasize the idea, we have two-dimensional components from east to west, from north to south. Those are two vectors, but they tell us that the movement is still one-dimensional. And based on this, we have to write the horizontal equation that they cancel each other out. But dimension along this axis, along these lines, they don't cancel each other out, they just work against each other in such a way that the speed in this direction is reduced, but still it's known because distance is known and time is known. And that's all about this problem. I hope you liked it. I hope you click subscribe, you click the bell, you click like, and I see you next time. Thank you.